Welcome to the Brainstorm Learning Center tutorial video.
I'm here to take on a topic called wave. What is wave? Wave is a disturbance which transfers energy from one point to another through a medium without actual displacement of the medium itself. That is, a wave is a disturbance which transfer energy through a medium from one point to another without actual displacement of the medium. Now this is just basic definition of the wave. No matter how you want to define yours, there are three keywords there. One, disturbance, energy, and mediums. That is, a wave is a disturbance which transfers energy through a medium from one point to another without actual displacement of the medium itself. Now, after the definition, let's now look at the classification of wave. Now, there are two basic criteria used to classify wave. That is, we are under classifications. Classifications of wave. One, we have what we call material medium. Two, we have mode of propagation or transmission. These are the two criteria used to classify waves. Let's take them one after the other. That is classification based on material medium. That is first one, based on the material medium. There are two types of wave. That's based on the material medium. There are two types of wave. The first one is mechanical wave, and then the second one is electromagnetic wave. Electromagnetic wave. So you have mechanical wave and electromagnetic wave. The first one, mechanical wave. What is mechanical wave? Mechanical wave is the types of wave that require material medium for the mode of propagation. That is, mechanical wave is the types of wave that require material medium that require material medium for propagation or transmission. E.g., I1, we have called water wave. II, you have sound wave. And then spring wave, etc. That is, without material medium, this type of wave will not be transmitted or propagated. For example, we cannot generate water wave without water. That is, water is a medium here. Also sound, the classes of matter like solid, liquid and gas are the major medium for the sound wave to propagated or transmitted. Spring, you need spring to generate spring wave. That is, spring is the material medium in case of spring. Why electromagnetic wave? The second classification, electromagnetic wave. Is the types of wave in which no material medium is required. That it does not require material mediums for the mode of propagation. That is the type of wave in which material medium was not required. Example are radio wave, 2, light, 3, X-ray, etc. Now, the major difference between mechanical and electromagnetic wave is just material medium. That is, mechanical wave require material medium, while electromagnetic wave does not require material medium. The second classification based on mode of propagation. There are two types of wave also. We have transverse. We have transverse wave, and then we have the longitudinal wave. These are the two types of wave under propagation. That is, based on mode of propagation, we have transverse wave and longitudinal wave. Let's take them one after the other. Transverse wave is the types of wave in which the direction of wave vibration is perpendicular to the direction of wave transmissions. That is the types of wave in which the direction of wave vibrations is perpendicular to the direction of wave propagation or transmission. That is, from this diagram, this direction of wave propagation, while the vertical axis is the direction of wave vibrations. Direction of wave vibration. Now, when you draw this line and intersect this, it will give what we call right angle triangle. Now, the typical example of this wave is known as what? Water wave and also light wave. That is, transverse wave is the type of wave in which direction of wave vibration is perpendicular to the direction of wave propagation. Or transmission. E.g., 1. Water wave. 2. Light wave. etc. This is just the definition from the diagram also. This direction of wave vibrations, direction of wave propagation, they are all both of them are perpendicular to each other. And a typical example of this is water wave and light wave. Now let's take the second classification, which is longitudinal. Longitudinal wave. Longitudinal wave. That's B. Longitudinal wave. In this case, the direction of wave vibration is parallel to the direction of wave transmission. That is the type of wave whereby the direction of wave vibration is parallel is the same or parallel to the direction of wave propagation. E.g., 1, we have sound wave and spring wave. etc. Now let's not look at that. Let's use diagram to explain the meaning of parallel or the same in terms of longitudinal wave. Now, for example, this spring wave this direction of wave vibration, right here is directions of wave propagations. Now, in terms of this example, this spring wave, this diagram of spring wave, here this direction of vibration, propagation. This is the direction of wave vibration. That's a typical example of what's called longitudinal wave. Also, in case of sound wave, when the air molecule is at equilibrium, the air molecules are well arranged in this pattern. This is also the direction of vibration, also the direction of what? Wave propagation. It's the same thing. That means that sound energy is longitudinal wave, while light wave is an example of what? Transverse wave. Because as time goes on, we are going to differentiate between light wave and what? And sound wave. What is the difference between light wave and sound wave? Let's interpolate their differences in a tabular form. Now this sound wave, this light. Let me continue. This light wave. One. Remember that sound wave require material medium. That shows that sound wave, example of what? Mechanical wave. That is, it require material medium for the mode of propagation. Remember that light is an example of electromagnetic wave. That no material medium is required. That is electromagnetic wave. That is does not require material medium. Second one, sound is longitudinal wave. The direction of wave vibration is the same to the direction of wave propagation. Now the second one here, that is what? Transverse wave. The direction of wave vibration is perpendicular to the direction of wave propagation. The third one, in terms of speed, the speed of sound in air, the speed of sound in air is 330 meters per second, while in case of light, the speed of light in air is 3 times 10 raised to the power of 8 meter per second. Now, because of this value, light energy or light wave propagates faster than sound wave. Let's recap. In terms of differences between sound wave and light wave, one, sound wave is a mechanical wave that is required material medium for mode of propagation. While light wave is electromagnetic wave does not require material medium. One. The second one, longitudinal wave, simply means that the direction of wave vibration is the same to the direction of what wave propagation. While in case of light wave, it's transverse wave, simply means that the direction of wave vibration is perpendicular to the direction of wave propagation. While the third one, the speed of sound in air is about 330 meters per second, while the speed of light in air is 3 times 10 raised to the power of 8 meters per second. Because of this value, light energy or light wave propagate faster than sound energy or sound wave in air. Now let's now look at terms used in wave. That is terms. Terms. This is example of transverse wave, which is water wave. Now from this diagram, the highest point of the wave, the highest point of wave is known as crest, while the minimum point of the wave is known as what? Trough. Therefore, the distance between the midpoint and the highest point is known as what? Amplitude. Now let's start from the word amplitude. One is amplitude. Amplitude in bracket A. Is the distance between the crest and the equilibrium point of the wave. The equilibrium point simply means is the point where there is no movement of the particle. That is, equilibrium point is the point where there is no movement of the particle. Hence, amplitude is measured measured in meter. That is m. That's the SI unit because it's distance, and then the unit of distance is what is the meter. That's the first one. That is the distance between the mean position or equilibrium point and the crest is known as amplitude. And then the equilibrium point simply means is the point where there is no movement of the of the particle. And then the SI unit of the amplitude is in meter. That's the first terms. The second terms period in bracket T